So, namaste one and all. So, let us look at the concept dipole in uniform electric field. So, let us consider a permanent dipole of dipole moment P in an uniform external field E. So, you know that dipole is nothing but two charges of equal magnitude but opposite charge separated by small distance 2a is called as a dipole. So, here one is of charge minus q and the other is charge plus q and they are separated by a distance 2a. So, this is called as dipole. And you also know that the direction of dipole is from minus q to plus q. So, this gives you the direction of dipole moment. So if there is a dipole moment without the existence of any electric field, then that would be called as a permanent dipole. Now we are considering a permanent dipole which is having a dipole moment from minus q to plus q. Now let us apply external field E, and that external field should be uniform. So let's consider we are applying external uniform electric field E. So we apply the external electric field E over the dipole. So when we apply external field, so that when we apply external field E, that produces force on both the charges. So the force experienced by positive charge is plus Q into E, and the force experienced by negative charge is again Q into E. But the direction is different. So in case of positive charge, so the direction of force will be in the direction of electric field, whereas in case of negative charge, the direction of force will be exactly opposite to that of the electric field. So although the force applied on both negative charge and positive charge are equal, so the net force would be cancelling out each other. So the force would be, since force are equal and but the direction of the force applied is opposite, so they would be cancelling out each other and the net force should be equal to 0. But the force is applied at one end and at the other end, so this tries to build up torque. So what happens is, since the force is applied at the end of at the last end here and the last end here, so although the net force is 0, so this results in something called as torque. So this torque tries to rotate this dipole. So this torque is rotating the dipole. So what is the magnitude of this torque? The magnitude of this torque is given by dipole moment cross electric field E, which can be written as PE sine theta. So where dipole moment P is nothing but charge multiplied by the distance between the charge, that is 2a. So when does this torque ends, or when will this torque become 0? So these torques will be trying to rotate the dipole until the dipole moment aligns with that of electric field. When the dipole moment aligns with that of electric field, then torque becomes 0. Look over here. So this is trying to rotate the dipole. So when this dipole moment is aligned with that of electric field, what happens? The torque would be 0. So now you are aware that in an uniform electric field, so the net force would be 0, but there will be a torque, and the magnitude of that torque is given by P cross E or PE sine theta, and that torque will become 0 when the dipole moment aligns with that of the electric field E. Whereas in case of a non-uniform electric field, if you look over here, so here the electric field is less, whereas here the electric field is more. So this electric field produces more force on this charge plus Q when compared to the force produced on this negative charge. So although the directions are opposite, but the force on this charge is more and when compared to the force on this. So the net charge, the net force will not cancel out. Okay. So in non-uniform electric field, there exists force. Along with the force, there also exists the torque. So there will be force and there will be torque. So this is regarding the dipole in an electric field, both in uniform and non-uniform electric field. So in an uniform electric field, there will be only torque, and that torque also becomes 0 when the dipole moment aligns with that of electric field, whereas in case of non-uniform electric field there will be force and there will be torque. I hope you have understood this concept. Thank you for watching the video. I hope you have understood the concept. So to know whether you have understood the concepts better, you need to answer the quiz. The link for the quiz is given in the description below. After answering the quiz, you will be getting the result. So retake the quiz until you find that you have answered all the answers correctly and got the complete out of out results.